Now, let's look at the hypothesis testing of our ANOVA procedure here. In step 1, we list hypothesis. And what is a hypothesis here? Well, we say mu1 equal to mu2 equal to mu3. And what does that mean? That means there are no differences among the mean of marriage length for the 3 what? Population. And H8, or you say H1, the research hypothesis, always say H0 is not true. Having said that, H0 is not true, what does that mean? The negation of this statement, all 3 are equal, is what? At least 2 of them are not equal, okay? At least 2 of them are not equal is a negation of H8, okay? When I say at least 2 of them are not equal, what does that mean? Well, it means, let me write this down. At least 2 of what? Mu i's are not equal. That means I can at least find a pair of what? Mu I and mu j. Okay? That mu I is not equal to mu j. Okay? I can find what? Mu I not equal to mu j for some what? Some I and j. Okay? At least 2 of mu i's are not equal. Okay? That is a negation of H0. Okay? And we choose alpha equal to 5%. And step 3, test statistic used. We use F statistic. And our decision is reject H0 if the observed F or the calculated F value is too big. As I mentioned in what? Earlier discussion. F is equal to MSG over MSE. Under the assumption that H0 is true, we expect to see X1 bar very close to X2 bar and very close to X3 bar. So X1 bar minus X bar should be very close to 0. Similar for what? The other 2 sample mean minus the population mean square should also be very close to 0. So that gives the conclusion that MSG should be very small. So when MSG divided by MSE, when we expect to see a small MSG, that is to say we expect to see what? F is small, under H0 is true. But if we find, we calculate or we obtain a large F value, that is support HA is true. So that's why we reject H0, okay? Now, step 4, let's look at calculation. Based on what we calculated earlier, we can summarize our calculation in an ANOVA table. And in the exam, you should also need to give me a similar one, ANOVA table, in your answer, okay? Now, let's look at the calculation. This is called ANOVA table, okay? Here I give you 1, 2, 3, 4, 5, 6 column, okay? Let's look at what's in the first column. Source of variation. Well, between groups, within groups, and total. Now, sum of squares between groups is what? 71.8. And within the group is what? 17.25. Okay? And these 2 numbers add up to what? These 2 numbers add up to 89.58. And what's the degree of freedom between groups? The degree of freedom is what? I minus 1. I is 3 population group, minus 1 is what? 2. So degree of freedom is 2. And within the group is total population size minus I. total population size is what? N, capital N. N is each group, 5 observation. 3 different groups, 3 population, 5 times 3 is what? Is 15. And how many groups? We have 3 groups, so 15 minus 3, which is 12. And look at here. Sum of squares between groups plus sum of square within group. They add up to what? Sum of square total. And the other identity is degree of freedom between groups and degree of freedom between within group. 2 plus 12 add up to what? Total degree of freedom, which is 14. Okay? And mean squares, MS, is sum of squares, 71.8 divided by 2, give me what? 75.9. And mean square within the group, okay? Within the group is SSE, which is 17.25 divided by 12 is what? 1.4375, okay? And these two numbers, 35.9 divided by 1.4375, the ratio is 24.98, okay? This number is 24.98. If we look at what? The F table. If we look at the F table, okay? What are we going to get? Now let's see. The degree of freedom between groups is 2. And this 2 is what? Is degree of freedom for numerator. And source of variation within the group. This is about what? SSE or MSE, okay? And the degree of freedom is 12. As you can see, one is 2, and the other one is what? 12. And intersection of the two give us what? Give us 3.88, okay? Give us 3.88. So, alpha equal to 5%. The critical F value is what? Is 3.88. So let me redraw a graph here and make the comparison. This is F with 2 degrees of freedom for numerator, 12 degrees of freedom for denominator. And 5% is what? Alpha equal to 5%. That means we chart off what? Top 5%. This is 5%. And the critical F value in this case is 3.88. And as we can see, F value is 24.98, is 24.98. Therefore, we can say p-value greater than 24.98 is what? Definitely less than what? 5%. So here we can say p-value is less than what? Less than 5%. P-value less than alpha equal 5%. P-value is really small. Therefore, we reject H naught. Okay? So we reject H naught at alpha equal 5%. Okay? Now, furthermore, I want to discuss about the relationship about SS what? Comments. On the relationship between SG and MSG. SSG divided by what? Divided by degree of freedom of SSG is MSG. In our case, SSG is 71.8. You can go back to look at the calculation procedure. You can find SSG is what? 71.8. And what is degree of freedom of SSG? It's the population size. No, it's not. Well, it's what? It's I minus 1. I is how many different groups we have. Okay? I minus 1. I in our case is 3. So 3 minus 1 is 2. 71.8 divided by 2. So that's why MSG is what? 35.90. Similarly, we can discuss SSE and what? And MSE. SSE divided by degree of freedom of SSE. SSE is 17.25 divided by its degree of freedom, which is population size minus how many group we have. In this case, 70.25 divided by 15 minus 3. And this number is what? 1.4375. Okay? And that's it for our ANOVA model F-test procedure.